Hi everybody, so today for our live stream we're going to be talking all about oceans. So before we start, I just want to say thanks to our sponsors. There's Actua and Promo Science. Without them we wouldn't be able to do everything that we do here at X-Chem. So before we start, there's a couple things we need to talk about. The first is, what is density? So density, in layman's terms, is the degree of compactness, or mathematically, it's mass per volume. So a good way to think about this is oil on water. So I don't know if you've seen the oil and water experiment before, but you'll notice that the oil sits on top of the water. That's because it's less dense. Another way to think about this is thinking about gases, liquids, and solids. Gases are less dense than liquids, and liquids are less dense than solids. So let's get started with our first experiment. So for this experiment, I'm using this tank with the divider. I'm going to be using some water, some table salt or sea salt, and then I have the water dyed so you can see how the experiment goes through. So I'm just going to take some pre-dyed water. The blue is going to act as my fresh water, and the yellow is going to act as my salt water. So I'm just going to go ahead and add some sea salt to it. We want to add a lot because this is mimicking seawater. And seawater is a lot saltier than some people think. So I'm just going to give that a stir until most of the salt is dissolved. What we're going to be testing here is how salt and fresh water interact in the real world. So what I'm going to do is, on one side of the tank, I'm going to put our blue fresh water. And then on the other, our yellow salt water. Now, when I release this, the two are going to mix. What do you guys think might happen? Keep in mind what I talked about before with density. So one of them is going to have salt in the mix, and the other one is just plain tap water. As well, if you do have some suggestions to what might happen, there is a bit of a lag between when we see your messages and not. So just keep that in mind. All right, I'm just going to go ahead and do it. So what you'll notice is happening, I'll move it back so you can see a little better. There's two very distinct layers of water. So on the top here is our fresh blue water, and on the bottom is our salty yellow water. So because salt water has a higher density than fresh water, it sinks to the bottom. So for our next experiment, I'm going to also need this tank. So I'm going to have my friend Callie empty this out for me. So again, why does this happen? Salt water is denser than fresh water. And a little fun fact is the area that they mix. So there was a little green line that you could distinctly see in the tank. It's called brackish water. There's lots of examples of brackish water all around the world. And there's a lot actually in Nova Scotia. Because we're right on the ocean, there's a lot of areas where rivers will flow into the ocean and create this area of brackish water. So how does this affect the environment? Well, there's some pros to this. Water circulation. So as you saw when I released the panel that was in between the two of these, there was a moment of circulation in the tank. Everything had to settle. So when these two types of water mix, it helps things that are on the bottom of the ocean be pushed up to the top and vice versa. So nutrients that settle to the bottom can come to the top of the water, and oxygen that's at the top of the water can go to the bottom of the water. However, there's also cons to this. Everybody knows about climate change and how it's affecting the world. So there's a lot of ice melting. Well, ice is all fresh water. And when that fresh water is introduced into the ocean, it's not really enough to cause the circulation, but it is affecting the amount of fresh water that's sitting on top of it, which can be harmful to wildlife. So the next experiment. In this experiment, we're going to be using hot and cold water, and we're going to be doing a very similar thing. So over here, I have some water that's near boiling. I'm going to use an oven mitt to get it because safety first. And this one is also dyed yellow. So both of these are just plain tap water, except one's going to be hot and one's going to be cold. Just going to hold the tank here because it seems like there's a bit of a seal that is leaking. And this is, again, just tap water. I had some ice in it earlier. Most of it's melted now, though. And it's still a nice blue color, even though a little bit of the yellow got into it. So, any ideas on what's going to happen when I mix the two of them together? Just going to turn the hot plate off. Any ideas? All right, I'm just going to go ahead and release the panel. And if you guys watch closely, you'll see how the two interact with each other. Now, like I said before, there's a moment of circulation, so you can kind of see that the blue is shifting from one side to the other before everything settles. But things are more or less settled now, and you can see it's similar to what happened with the salt and fresh water. On the top, it's mostly yellow. On the bottom, it's mostly blue. And again, there's a little line of green in the middle where the two are interacting directly. So this happens for a very similar reason to the salt and fresh water. Hot water is less dense than cold water. Cold water is closer to the solid state. So like I said before, solids are more dense than liquids. And the hot water is closer to the gas phase, and gases are less dense than liquids. So what does all this mean? So in the ocean, there's a process called deep water formation. So in essence, high salinity and cold temperatures equals deep water, because the saltiest water and the coldest water is going to sink to the bottom. And like I said before, all of this has to do with ocean circulation. So when hot water is on the top of the water and it first is introduced, it helps everything circulate. It helps oxygen and other parts of the ocean that's sitting on top go to the bottom. And then once it goes down and it pushes the cold water up, the cold water brings nutrients from the bottom of the ocean. And then there's a whole cycle. When the cold water comes up, it heats up, eventually gets pushed down, and so on and so on. So I'm going to move the tank aside. I have one more demonstration for you guys today. And it's all about how animals keep warm in these deep, cold, salty waters. So think the Arctic or the Antarctic. So there's two types of ocean creatures I'm going to talk about: warm-blooded and cold-blooded. Warm-blooded creatures include things like whales, seals, cats, dogs. You and me are cold-blooded, and that's because we naturally produce heat from the circulation of our blood. As well, we also have fatty layers. And cold-blooded creatures, such as like fish and sharks, when they're in colder environments, their metabolisms actually slow down so that they don't need as much heat. As well, a lot of them that are used to being in cold environments will have special fats and enzymes in their blood so that their blood doesn't freeze. So there's an experiment you can do with this, and you can do this at home as well. You just need a few items to be able to do it. So the first thing you need is a bath of very cold water. So you can still see there's a lot of ice floating around in there. It's cold. The second thing you're going to need is shortening, or some other kind of fatty kitchen good will probably work as well. And as you can see, I have the shortening in a plastic baggie all ready to go. And the last thing I'm going to be using is plastic glove so I don't get the shortening all over me. This is optional, but just make sure that you wash your hands really well after if you don't use a plastic glove. So in this experiment, if I was to stick my hand in this water, it's cold. I can't leave my hand in there. It's really cold. But the shortening is going to represent blubber, while the baggy is going to represent the waterproof skin of an animal such as a seal or whale, or the waterproof feathers of a penguin. What I'm going to do is I'm just going to stick my hand in the baggie with the shortening. And this is going to show you how those kinds of animals stay warm. So if I stick my hand in here, I could leave it in here all day. It's not cold. I don't even feel the cold because the fat insulates very well against cold. And then the waterproof bag stops water from being able to penetrate the fat and stop it from insulating. So I'm going to move that aside and take off this glove. That is the end of our experiments for today, all about oceans. We learned about deep water formation. We learned about how animals keep warm. But if there's any other questions you want me to answer, feel free to ask them now. If you have any questions, we'll get to them, and my friend Callie will send them to me. If I don't catch them, maybe there was already some, but I didn't see them, and those will get sent to me now. So there's a lot of talk about how plastic is bad for the oceans. That's a really good topic, and we might consider doing it for another live video a different day. Somebody asked a question, how can you make fire with sticks? All right, so the way you would make fire with sticks is actually about friction. So friction is a force that all of us feel. So for example, if I was to rub my hand across this, there is a bit of resistance. But if I was to rub something rubber across it, it's harder to because it has more friction against the table. So when you're trying to make a fire with sticks, when you rub them together, it creates a lot of friction. And friction has the ability to create heat. So when you have all the components to make a fire, you need fuel, oxygen, and heat. Rubbing the sticks together provides one of those components. Any other questions? Remember, there is a delay, so if you ask a question, I might not see it right away. All right, it doesn't look like there's any more questions. I haven't had any other ones sent to me. So that's everything for our live stream today. We have another one tomorrow at 2 o'clock, all about water again for our water theme week. That was a very good question. So yeah, thank you everybody. And we hope to see you tomorrow or next week for more of our live videos. Thanks.